Alright, boys and girls, I wanted to do a quick video. Friday I said that I would do this as a gift to you for all of my people who have been working hard for the third quarter. I wanted to kind of show you how to use Zern and how to use the Eureka problem sets and how you can use both of those to compare or to make sure that you are getting everything you need out of the total math curriculum and all of your resources. So let's take a look here. So first, this is just talking about the independent practice or the Tower of Power in Zern and just strictly the problem set. There's going to be other elements of the lessons, and here you can see for lesson 23, which was scale it, and the objective was to compare the size of the product to the size of the factors. And you had the fluency, you had the guided practice, and then you had the independent practice as well as a bonus. I'm just focusing on the independent practice here, and at this point, you should have a good understanding of the lesson or of the objective, and we're going to go ahead and test that now. So let's look at the first problem here. It says, will the product be less than 18 7/10, equal to 18 7/10, or greater than 18 7/10? All right, so because we have 18 7/10 multiple times here, we know that that's not our scaling factor. Our scaling factor is going to be our other factor, which in this case is 1.0. And what do we know about 1? Hopefully you said anything times 1 equals itself, so therefore this would be our correct answer. 18 7/10 times 1 is equal to 18 7/10. All right, the next two problems, and feel free to push pause so you can get a little bit of think time, and that way you'll have a chance to test and see if you know this on your own, and you're not just listening to the video as if it's a movie. All right, so let's take a look at this next problem. Will the product be less than 18 7/10, equal to 18 7/10, or greater than 18 7/10? All right, so we know that our scaling factor here is 92 hundredths. So because we have 92 hundredths as our scaling factor, we can say that, give me 1 second here, let me pop out my pen. We know 92 hundredths is less than 1. So we're multiplying one factor by another factor that's less than 1. So therefore, our product is going to be less than our original factor or our starting factor. In this case, the product of this, when we multiply 18 7/10 times 92 hundredths, is going to be less than 18 7/10 because 92 hundredths is less than 1. All right. Same thing. Will our product be less than, greater than, or equal to 18 7/10? Now, our scaling factor is 1 3/10. We know that 1 3/10 is it greater than, less than, or equal to 1? Hopefully you said it's greater than 1. So because 1 3/10 is greater than 1, the product, remember product is the answer. We're talking about factor times factor equals product. We're talking about the answer to this problem is going to be greater than our first our first factor, which is 18 7/10. You know it's going to be greater. And I mean, I wouldn't suggest you do this, but you could go ahead and write out the multiplication sentence in standard algorithm and multiply it out. But that's just a check that you can do if you're still unsure. But I know because this is true, 1 3/10 is greater than 1. I know that the product of 18 7/10 times 1 3/10 is going to be greater than 18 7/10. Feel free to push pause. I know I'm throwing around a lot of vocabulary. Factor times factor equals product, greater than, less than, equal to. That's why I'm shooting this video, so you can go at your own pace and say, well, what did he say? I need to bring that back. Press the rewind button and you can go ahead and bring it back and listen to it again. Okay, let's move on to the next problem here. It says fill in the blank using one of the scaling factors. So we're going to use one of the scaling factors to make the number sentence true. So I'm looking here. I have 1 8/10 times blank is greater than. So I need to put in a number here that's greater than 1 because I know 1 would be equal to 1 8/10. So the only number that's greater than 1 here is 1 3/1000. All right. So if I put 1 3/1000 in there and I multiplied it by 1 and 8/10, it's going to be greater than 1 and 8/10. Same thing here, or actually in the opposite way now. 1 and 8/10 times blank is less than 1 and 8/10. So I need something that's less than 1. The only number of these three that's less than 1 is 951, and that one's in the thousands place. So you say that 951 thousandths. All right, now this is the easiest of the three. 1 and 8/10 is equal to, 1 and 8/10 times blank is equal to 1 and 8/10. We know that 1 is going to be our answer there. I wrote it without the decimals. So that is correct. And we could check that by doing the standard algorithm of multiplication. However, if you know that 1 is equal to 1, I'll just write it the form that they had it. Therefore, I know that if I multiply by 1, I'm going to get the same number. In this case, it's 1 and 8/10 for all of them. I know that 951 thousandths is less than 1. So therefore, I know that this statement is true. And I know that 1 and 3 thousandths is greater than 1. So that the understanding of my scaling factors in relationship to the number 1 will help me determine what number goes in each. And that's what we're always looking at. You have to identify that scaling factor and then say, well, is the scaling factor greater than or less than 1? And then that's going to give you the idea of what your answer is going to be for all of these problems. All right, same thing here. I don't think I selected this one, so I might have to rewrite this one. On the next one, I made them drag and drop. So it says sort the expressions. Start by sorting the expression below. So we're going to either put this over here or over here based off of which category it goes in. We're sorting. It says the product. So when I multiply 470 and 8/100 times 6/10, is the product less than the number underlined, or is the product greater than the number underlined? So I'm comparing it to this, so I know that this is my scaling factor. So I'm saying is 470 and 8/100 times 6/10 greater than, less than, or equal to 470 and 8/100. So because I know I'm comparing this number to itself here, I know that this is my scaling factor. So my scaling factor, is it greater than or less than 1? So let's ask ourselves, 6/10, is it greater than or less than 1? Hopefully everybody said, put it in, less than. Thank you. So because my scaling factor is less than 1, I know that if I'm multiplying 470 and 8/100 times a number less than 1, it's going to give me a number less than 470 and 8/100. So it should be over here. All right, let's take a look at the next couple problems here. So now we're doing the same thing. We're going to sort the expressions, and we're comparing it. Is the product is less than the number underlined, or the product is greater than the number underlined? So let's take a look here. So because we're comparing the product to the number that's underlined, we know that our scaling factor is the other number. So let's go ahead and circle all of our scaling factors, and that's going to make it really easy for us, because we're just going to say, is our scaling factor greater than 1 or less than 1? And we're going to, if it's greater than 1, we're going to put it over here, and if it's less than 1, we're going to put it over here. All right. So we're looking at our scaling factor of 871 thousandths. 871 thousandths is less than 1, so I know that this is going to be, the product is going to be less than 4/10. All right. So now next we have 17 and 23/100 times our scaling factor of 1 and 49/100. Excuse me. So 1 and 49/100 is greater than 1. So our product is going to be greater than 17 and 23/100. Next, 409 times 1 and 6 thousandths. 1 and 6 thousandths is greater than 1. So the product of these two factors is going to be greater than 409. Next, we have 870 times 5 and 21 thousandths. 5 and 21 thousandths is greater than 1. So our product of these two numbers is going to be greater than 870. Last but not least, 231 1100ths times 96 thousandths. 96 thousandths is less than 1, so the product of those two numbers is going to be less than 231 1100ths. All right, and once again, the way I did this, I just looked at the scaling factor and said scaling factor was 871 thousandths, and we said that that's less than 1. So we know that this is going to go on this side here, less than side. Next one, 1 and 49 hundredths is greater than 1. So we know that that went over here. Then we said 1 and 6 thousandths is greater than 1. So we know that that was also on the greater than side. Our product is going to be greater than our first factor. Finally, we said 5 and 21 thousandths is greater than 1. So our product is going to be greater than 870. And lastly, 96 thousandths is less than 1. So our product is going to be over here on the less than for our first factor. All right. So it all depends on the relationship of your scaling factor to the number 1. All right, let's go ahead and take a look at our problem set now. So it says fill in the blank using one of the following scaling factors, let's underline that, to make each number sentence true. So now we know that we have an equal sign here, so automatically when you see that equal sign, you know it's going to be your 1. All right, anything times 1 equals itself. So in this case, 3 and 4 tenths times 1 equals 3 and 4 tenths. Now, we have a greater than sign. So we know we need a number that's greater than 1 for our scaling factor. The only number that's greater than 1 is this number here, which is 1 and 21 thousandths. So 1 and 21 thousandths times 21 hundredths is going to be greater than 21 hundredths. All right, and then lastly, we have a less than sign. The only number that's less than 1 is 989 thousandths. So we know that 8 and 4 hundredths times 989 thousandths is less than 8 and 4 hundredths. Moving on. Same thing like we did in Zern. We're just going to sort. They're telling me to sort the following expressions by rewriting them in the table. And it says the product is less than the box number or the product is greater than the box number. So I know that I'm going to circle all my scaling factors. That's why I think it was lesson 21, our task was to circle our scaling factors so that we can identify those scaling factors. 1 and 4 thousandths is greater than 1, so I'm going to rewrite that expression there. Remember, I'm just looking at my scaling factors. 69 thousandths is less than 1, so I'm going to rewrite this expression here. Because I know when I multiply 69 thousandths times 3 tenths, it's going to be less than 3 tenths. All right, same thing. 489 thousandths is less than 1, so I'm going to rewrite this expression here. Next, 1 and 24 hundredths is greater than 1, so I'm going to rewrite this expression here. Because the product of 1 and 24 hundredths times 72 hundredths is going to be greater than 72 hundredths. Last two, I know that this is going to be on my greater than side because 4 and 15 thousandths is greater than 1. And lastly, my scaling factor here is less than 1, so it's going to go on the less than 1 side. All right, because when I multiply 2 tenths times 1 tenth, it's going to give me a number that's less than 2 tenths, less than the box number. All right, explain your sorting by writing a sentence that tells what the expressions in each column of the table have in common. All right, and it was a long sentence, so I decided to just go ahead and type it out. And B says, explain your sorting by writing a sentence that tells what the expression in each column of the table have in common. So we're talking about each column, the rows go side to side, columns go up and down. So what does this column have in common and what does this column have in common? So I put in the less than box, that's this box over here on the left, all of the scaling factors are less than 1. So let's go ahead and highlight those factors that we're referring to. And we'll do that we'll highlight those in yellow. So here's one factor that's less than 1. That's another scaling factor that's less than 1. And that's another scaling factor that's less than 1. And in the more than box, so this box over here, all of the scaling factors are more than 1. So that's what they have in common. Let's look at this. That's my scaling factor that's more than 1 here. Another scaling factor and another scaling factor. Now somebody may say, well, how do you know which one is a scaling factor? Why wasn't 13 and 89 hundredths a scaling factor here? Because remember, it says the product is less than the box number. So the box number is going to be compared to. So we're saying basically here what we're doing is we're putting a greater than, less than, or equal to sign, and then we're rewriting the box number. So because this repeats, you know that the other number is your scaling factor. And this would be greater than. That's why we check that off, okay? So that's how we know it's our scaling factor, because they asked us if it was greater than, less than, or equal to, or excuse me, greater than or less than the box number. So this is what we will be looking at here. And we know that that was less than. Product of those two are less than the box number. So that's how we came up with those scaling factors. All right, let's go ahead and pick up the pace here. All right, now what we're going to do is we're going to write a statement using one of the following phrases to compare the value of the expressions. And then you're going to explain how you know, okay? So let's go ahead and do this. And if you notice here, we're comparing 4 and 4 here. So our scaling factor is here. Here we have 8 tenths and 8 tenths. So we know our scaling factor is here. And because this number here is very close to 1, 988, we can round this up to 99 hundredths, which is 1 away from 1. That's like if you got 99 out of 100 on a test, or 988 out of 1,000. All right, we know that that's going to be slightly less, because this is slightly less than 1, then this is going to be slightly less than 4. All right, and it's simply because this number, our scaling factor, is slightly less than 1. Same thing here. Our scaling factor is the 1 and 5 hundredths. That's just a little bit over 1, right? If you were talking about $1, this is $1.05. That's slightly over 1, right? So therefore, this is going to be slightly more than, for our answer, slightly more than 8 tenths. All right, let's go ahead and take a look at the next two. Now, remember, I'm talking about 1,725, comparing it to 1,725. So my scaling factor is 13 hundredths. Same thing here. My scaling factor, look at what I'm comparing. These numbers are the same, so my scaling factor is the one that's not related to this here. Same thing here. These numbers are the same. My scaling factor is here. For C, D, and E, we're looking at all three of our scaling factors. I know that 13 thousandths is just over 1 penny. It's between 1 and 2 pennies. We don't have coins that represent thousands, but if we did, it would be less than 2 pennies. That's a lot less than 1. 1 penny is a lot less than 1, so I'm going to say that the product of 1,725 times 13 thousandths is going to be a lot less than 1,725. All right, and now here, look at my scaling factor. My scaling factor is 989 and 1,000. We're comparing that to 1. That's a lot more than 1. If I had $1 and somebody had $989, and they say, well, we have around the same amount of money. No, they have a lot more than me. So this is going to be, is a lot, what? Is it a lot less or a lot more? Hopefully you said a lot more than, because our scaling factor is a lot more than 1. All right? And I'm explaining how I know by just that because statement. So it'll be because my scaling factor is a lot more than 1. All right? And now here, I know that my scaling factor is around 91 hundredths. 911 thousandths is around 91 hundredths. 91 hundredths will be 91% on the test. 91 out of 100, or 911 out of 1,000. So I know that this is slightly less than 1. So therefore, the product of these two numbers is going to be slightly less than this number here. All right, and I'm not going to write the because for E and C, but it's going to be similar to this. because my scaling factor is, and then it's either going to be whatever this says. Yours is going to be because, for C, it will be because my scaling factor is a lot less than 1. And then this will be because my scaling factor is slightly less than 1. All right? Last one we're going to look at here. It says, complete the following statement, then use decimals to give an example of each. So let's go ahead and look at this. It says A times B is greater than A will always be true when B is blank. And we know, we can say, well, we're talking about B is going to be my scaling factor because I have A and A here, right? So if we're talking about B as our scaling factor, then B has to be greater than what? What number goes there? Hopefully you said 1. All right, and then it says to use decimals to give an example. So we'll say 25 hundredths times, we need a decimal that's greater than 1. We're just going to say 1.1 is greater than 25. All right, so if I have more than 1 here, I have 25 plus 1/10 of 25, it's going to be greater than 25. All right, A times B is less than A will always be true when B is, instead of greater than, it's going to be the opposite. Less than 1. All right, and then we're going to use the same numbers here, 25. Now instead of something that's greater than 1, like I did for this first one, I'm going to put something that's less than 1. So I'm just going to put so 25 hundredths. All right, so now look at this. This is saying that you have almost have a quarter. You don't quite have a quarter. You have 99% of a quarter. So that's going to be less than a quarter. This is saying you have a quarter plus 1/10 of a quarter. So that's going to be more than a quarter. All right? And it's all about the relationship of your scaling factor, which was B here. B is your scaling factor in relationship to 1. So it's the relationship that your scaling factor, B is less than 1 here, and here B is greater than 1. All right. Thank you, boys and girls. This is a rather long video, but I hope please use this video in the right way by going through the video, pushing pause if you need to, and seeing how you compare to the answers. If you see any mistakes, please feel free to comment. I have some people who are constantly commenting. I greatly appreciate it. Like, subscribe, do all of that good stuff. I hope this is helpful, and it adds another dimension or another chance for you to get some learning done. As always, don't be good, be great.